Hello everyone, welcome to Equal To, and this is episode 28 of a polynomial series, and this is going to be the last episode of the polynomial playlist. Okay, so we are almost at the end of this exercise 2.4 and we have 3 more questions left that we'll be solving in this video. Okay, now if you remember in the previous video, I hope you have watched it. If you haven't, please go and watch that first, because the identity that we learned there, that is what you're going to use here. So we did something in the 13th question, which was we proved that if x plus y plus z is equal to 0, then x cube plus y cube plus z cube is equal to 3xyz. Now this was a question that had to be proved in the previous question. Okay, now we have proved that if x plus y plus z is 0, then x cube plus y cube plus z cube is equal to 3xyz. Okay, now that is what we are going to apply to solve this 14th question. Okay, so let me just read the question first. Without actually calculating the cubes, find the value of each of the following. Okay, so that is the question. The first subdivision here is minus 12 the whole cube plus 7 the whole cube plus 5 the whole cube. Now if you could observe something, minus 12 plus 7 plus 5. If you add these three numbers, that comes out to 0. Okay, now this is why I wanted you to know about the previous question right now. Okay, because if x, y and z and their sum is 0, if x plus y plus z is equal to 0, then you can say that x cube plus y cube plus z cube is equal to 3xyz if x plus y plus z is equal to 0. In this case, obviously x plus y plus z is equal to 0. Then you can straight away find this x cube plus y cube plus z cube by 3xyz. Okay, you can just multiply x, y, z and 3 and that will be the answer. So let us just do that. 3 into x here is minus 12 and y here is 7 and z here is 5. Okay, we're going to multiply these things now. So 7 times 5 is 35, that we know, and 35 times 12, or rather what you can do is 3 times 12 is 36, right? So this is minus 36 into 35. Okay, so you can multiply 35 and 36, but I'm going to do it differently. We are first going to find what 35 into 35 is, and we are going to add a 35 to that. Okay, now I hope this is easy. Actually, I'm just trying to get you to do this faster. It might sound slower for now, but it will be faster later. Okay, instead of multiplying 35 by 36, you can multiply 35 by 35, because a number ending with 5, square of that number is easy to find. That is a trick that we have seen in our math trick shots, right? So 35 times 35, how do we find 35 square? It's 5 times 5, that is 25, and 3 times 4, that is 12. So 1225 is 35 square. You can just straight away add 35 to that. So that is going to be 0, 1. So 1260. Okay, 1260 is actually 35 times 36. If you don't want to do this fancy step, you can just straight away multiply 35 by 36. That would be simpler for you, but this would be much faster. Okay, so 35 times 36 is basically 35 times 35 plus 35, right? So that is what we have done here. So the answer is going to be minus 1260. Okay, so that is the answer to this question. Okay, you can just straight away use the 35 into 36 multiplication. It's no big deal, but this is something that you can do. It's a trick and it's faster, significantly faster. Okay, moving on to the next subdivision here. So 28 the whole cube minus 15 the whole cube minus 13 the whole cube. Now again, you are going to apply the same formula here. Let us just first verify if x plus y plus z is equal to 0. So 28 minus 15 minus 13. Now minus 15 and minus 13, when they add, that becomes minus 28. So that comes out to 0. So in this case, x plus y plus z is equal to 0. So you can tell that x cube plus y cube plus z cube is equal to 3xyz. Okay. Now obviously x plus y plus z is equal to 0. So you are going to just find out 3xyz. So 3 into 28 into minus 15 into minus 13. Okay, these are quite a large numbers. Okay, you just have to multiply them. Let us just first find out what 13 times 15 is. Okay, again there is something that you can do. For simplicity's sake, you can just multiply, but what you can do is, 13 squared is 169. Right, this is something that we know off the top of our mind. You can add 26 to that. Why 26? 26 is 13 times 2. So 13 times 15 is actually 13 times 13 plus 13 times 2. Right, this is actually 13 times 15. Why is that? We have 13 as a common factor in these two numbers, so you can take that out, and that leaves you with 13 plus 2. So that is basically 13 times 15. Okay, I'm just doing these things. These are totally unnecessary, but it might be easier for you to calculate and a faster way for you to calculate. Okay, you can straight away use that. It's no, like, there is no harm in doing that. So, but I feel this is quite a bit faster. So it's going to be 15 carry over 1, so that is going to be 7 plus 2 9, so 195. You can just straight away do this as a normal multiplication. So it's 5 times 3, that is 15. You have a remainder 1. 5 times 1 is 5. 5 plus 1 is 6, and 1 3, and if you add this, it's going to be 195. Okay, you can do this straight away, it's no problem, but that might be faster for you. Okay, so we have 3 into 28 into negative and negative. When we multiply to a negative number, it becomes a positive number, right? So it just becomes positive 195. Now we have to multiply these remaining numbers. So what are the numbers that we have here? Let us first multiply 28 times 3. 28 times 3 is 8 times 3 is 24. We have remaining 2. 3 times 2 is 6. 6 plus 2 is 8. 84. Right. So 195 multiplied by 84. It's going to be quite a large number. 5 times 4 is 20. Remaining 2. 9 times 4 is 36. 36 plus 2 is 38. And we have a remaining 3. 4 times 1 is 4. 4 plus 3 is 7. 8 times 5 is 40. We have a remainder 4. 8 times 9 is 72. 72 plus 4 is 76. We have a remaining 7. 8 times 1 is 8. 8 plus 7 is 15. So when you add, you get 0, 8 and 13, 16380. Okay, so that is the answer that you get, 16380. Okay, so that is all. I hope you understood this. X plus y plus z, if it is 0, you can use the expansion x cube plus y cube plus z cube equal to 3xyz. Okay, I don't want this video to be too so long. I'll just move faster with the next questions. And we are at the 15th question. Give possible expressions for length and breadth of each of the following rectangles in which areas are given as a polynomial. Okay, we are given area of a rectangle and you're supposed to find the possible lengths. Okay, what might be a length for this rectangle? Okay, we are given area. So what is area? Area for a rectangle is basically is equal to length into breadth, right? And we have this area to be a polynomial, to be precise a quadratic polynomial. Now if you want to express this quadratic polynomial in terms of product of two numbers, we have done something very similar to this already, which was what we call as factorization. Okay, so we are just going to factorize this polynomial and the factors are going to be possible values of L and B. Okay, now how do we factorize a quadratic polynomial? for the past two exercises we have been using identities only, but the exercise before that we were using a technique called I method. I hope you remember that. So how do we do the I method? We are going to multiply the coefficient of a squared and the constant term, so that is going to be 25 and 12. I think that is 300. Let me just multiply to check. So 5 times 2 is 10. We have remaining 1. 2 times 2 is 4. 4 plus 1 is 5. And this is going to be 25. So 0, 0, 300. Yeah. So the product of these numbers is going to be 300 and their sum is going to be minus 35. Since the sum is minus 35 and the product is positive 300, both these numbers should be negative numbers. Okay, so we have to find a pair of numbers whose product is 300 and whose sum is 35. Okay, 300, you can, how can you express 300? Obvious answer is 30 into 10. 30 into 10 is 300, but 30 plus 10 is 40, right? So that is not possible. Another thing that you can think of is 20 into 15. Okay, it's just trial and error. You can just try with different values. So 20 into 15, when you multiply it is 300 and 20 plus 15 is in fact 35. Okay, so 20 and 15 are two possible values. So minus 20 and minus 15, when you multiply them, you get positive 300 and when you add them, it's minus 35. Okay, so that is how we are going to factorize this. So 25a squared minus 20a minus 15a plus 12. Okay, from the first two terms, what can you take as a common factor? 5 can be taken, right? 5a. When you take 5a, you are left with 5a minus 4. Okay, and from these two, you can take 3. Right, 3 is a common factor for 15 and 12. Now again, this is a very simple method that we have been doing for a very long time. You know this by now. Okay, so when you take 3 as a common factor, you are left with, minus 3 as a common factor, you are left with 5a minus 4 again. Okay, so from these two, you can take 5a minus 4 as a common factor and that leaves you with 5a minus 3. So 5a minus 4 into 5a minus 3 is the factorized form of that polynomial and hence these can be the possible values of L and B. Okay, that is it. Moving on to the next subdivision, you need to be quick about it. It's the same process. We are going to factorize this number. It's essentially factorization. Okay, there is nothing fancy here. It's just worded differently. Okay, so 35 into 12, what is that going to be? 5 times 2 is 10, remaining 1. 3 times 2 is 6. 6 plus 1 is 7 and a 35 here. So 0 and this is going to be 12 and 420. Okay, so the product is 420 and the sum is going to be 13. Now this is not just 420, it's minus 420 because this constant term is a negative term. So the product should be minus 420 and the sum should be 13. Okay, so since it can be minus 420, it means that the it's going to be two numbers, right? Product of two numbers, which is going to be minus 420 and the sum should be 13, right? What can be like, you can try out with multiple things. You can start with 20 and 20 multiplied by what number would be like, we are just trying to find a middle point and you're going to think if you can go left or right. Okay, just a trial and error method. So if it is 20, it's going to be 21, right? 21 times 2 is 42, right? So 21 times 20 is 420. So 20 into 21 is one viable option and one of them can be negative, but 20 minus 21 or 21 minus 20, it doesn't really give you 13. So that is not a possible one. You can convert this into 21, but then this becomes 20, so it doesn't really matter. If you convert this to 22, is 22 really a factor of 42? No, you cannot multiply any whole number to 22, that becomes 42. So 22 is not possible. 23 is also not possible, but 28 can be a viable option. Okay, 28 into what should it be? 420 minus divided by 28. So it's 7 times 4 is 28, right? And 7 times 5 is 35, 7 times 6 is 42. So it can be like the 60 divided by 4, and you can further simplify this as this is going to be 2, this is going to be 30, and this is going to be 1, and this is going to be 15. So 28 times 15 is a viable option. Okay, 28 into 15. 28 into 15 is 420, and if we have 28 minus 15, that gives you 13. Okay, 28 minus 15 is 13, right? So this can be one option. So 35y squared plus 28y minus 15y minus 12. Now from the first two terms, what is the number that can be taken as a common factor? 7 is a common factor, right? 7y, so that leaves you with 5y plus 4, because 7 times 4 is 28 and 7 times 5 is 35. From these two, you can take minus 3 as a common factor, so that leaves you with 5y plus 4, again 5y plus 4. So 5y plus 4 can be taken as a common factor, and 7y minus 3 you are left with, and this is the two factors for this question. So that is the possible values of length. Okay, it's all about trial and error. You can just try out with different numbers that multiply up to 420, negative 420, and add up to positive 13. Okay, the faster you find that number, the faster you can solve this question. Okay, now moving to the next question. This also again is similar to the previous question, but with a slight twist. Okay, let me read the question first. What are the possible expressions for dimensions of cuboids whose volumes are given below? Okay, in the previous question it was area of rectangles. Here volume of cuboids. Okay, so basically you're going to find three factors. So that is all the difference that is going to be here. Okay, we have this polynomial 3x squared minus 12x. Okay, this is not a cubic polynomial, so you cannot find like you cannot factorize that way. So you're just trying to find factors within this itself. Okay, now from these two terms you can see 3x is a common factor, right? So that leaves you with x minus 4. Now this is something that's obvious. You can, when you see itself, you know that 3x is a common factor, and when you take 3x as a common factor, it gets you x minus 4 as the other term. So it can be written as 3x and x minus 4, right? 3 into x minus 4. So these three are factors of this polynomial, and hence these can be possible values of length, breadth, and height for this question. Okay, nice and easy, quick, easier to solve because that was a easy polynomial. Now here we have another polynomial, the same question at the subdivision, 12ky squared plus 8ky minus 20k. Okay, now in these three terms you can see 4 is a common factor for all the coefficients. 12 is a product of, like, 4 times 3 is 12, and 4 times 2 is 8, and 4 times 5 is 20. So 4 is a common factor for all these terms, and k is also a common factor. So when you take that out, that leaves you with 3y squared plus 2y minus 5. Now you can just straight away tell 4 is one factor, k is one factor, and 3y squared plus 2y minus 5 is another factor, but you can further factorize this 3y squared plus 2y minus 5, right? So you're going to do that again, I method. So 3 times minus 5 is going to be minus 15, and we have 2 here. So 3, 5 is 15, right? And we have positive 2 here, so minus 3 can be here. So minus 3 times 5 is minus 15, and minus 3 plus 5 is 2. So those can be our possible numbers. So 4k into 3y squared minus 3y plus 5y minus 5. Okay, so 4k into 3y into y minus 1 plus 5 into y minus 1. Okay, again 4k into, you can take y minus 1 as a common factor here, and that leaves you with 3y plus 5. Okay, so these are the factors that we have. 4k is one factor, y minus 1 is another factor, and 3y plus 5 is another factor. So these are the factors, and those can be possible values of length, breadth and height. Okay, now with that we have finished this exercise, and that is all for this chapter. If you have any doubts, please feel free to put them in the comments. I'll get back to you as soon as possible. See you in the next chapter. Bye for now.